packages and seasonal adjustment. Tim is going to talk about his package for doing weekly seasonal adjustment, and I'm going to talk briefly about my graphics package, my BLS plot GG package. Tim has a 20-minute talk. I have a lightning session. I'll try to keep myself to 7 minutes, but I tend to be quite expansive. But I think we have enough time, and then we'll have questions afterwards. I'm going to do the obligatory apology I always do. The office dog is with us now, and she may make herself heard on occasions. So I think we have enough people in the room. So Tim, I'm going to give you a 15-minute warning. I'm going to set my alarm to give you a 15-minute warning when you have 5 minutes to go, and then if I need to, I'll give you a 1-minute warning. Is that all right?
Yeah, sure. Thank you.
Okay. So why don't we get started? Tim, if you could share your screen, and we'll get underway.
Just a second. Do you see my slides?
Yes, right. I can see your slides.
Oh, yes, thanks. Today I'm going to talk about the seasonal adjustment of weekly data and an application in R. Just a brief background on this project. A few years ago, like in many other central banks, so my work is primarily focused on macroeconomic forecasting and modeling. And we considered developing a weekly tracker of economic activity, and was surprised to discover that there are no packages on cron dedicated to seasonal adjustment. The only available option then was a MUBREC program, which is available from SAS and EVIUS, and also there was something RJ Demetra, a fractional airline model. If I look, yes. It was quite inconvenient using like EVIUS because most of our development is in R. So combining like EVIUS or SAS, it works a bit sloppy. So initially, my intention was to just develop an open source alternative of MUBREC, or a version of MUBREC, let's say. So at the end, it is with a few adjustments to facilitate automation and simplicity. So let's just briefly see what is so special about weekly data and why we cannot implement conventional statistical methods on it. What you typically see in textbooks or in other papers is that in high frequency data you may have different number of weeks in a month or a year, and there are multiple seasonal cycles. For instance, in weekly data we have intra-monthly and intra-yearly cycles. But I think that the biggest problem is something that I at least refer to moving window problem, which is I kind of see being less well explained, at least in the literature, is something that I illustrate in the plot below. So I created, so this black line represents an artificial, so what happens with weekly data that we unobserved, we unobserved the associated daily data. So we have some sort of aggregation, or we observe it at the endpoints or something like that. So what I created is a very simple constant seasonal pattern of just linear decrease over the course of the month for the first 6 months of 2023. And these blue windows represent the first week of each month. And the green triangles are the mean of the black line within each window. And so what we can see here is that even though the underlying daily pattern is extremely simple and it's deterministic, the resulting weekly seasonality is much more complex. because each week aligns with a different portion of the intramonthly cycle. So, and this kind of limits the application of methods assuming a constant number of seasonal periods in a cycle, and or that they evolve smoothly, because as we can see, they do not. I guess the amount of the severity of bias is case dependent, and in applications where we have only a single intra-yearly cycle, it would be less severe, I guess, and what's visible. So I'm going to show a few examples. The first one is the weekly number of initial registrations in the Israeli Employment Service, which we see on the top. What is quite evident is that we have every year we have 3 large peaks, with the last one occurring somewhere in the August or in the beginning of September, that are related to seasonal workers. In addition, we have 2 declines that are related to moving holidays, where we have no registrations. To visualize the seasonal pattern, I created a few simple plots below. So on the left, we can see the box plot of initial registrations by the number of weeks in a month. So it kind of resembles the examples that I showed before. We have more registrations in the beginning of the month because most employment contracts conclude towards the end of the month, and then people hurry up to register because otherwise they're going to lose benefits. And if you look at the week number in a year, we also can see the pronounced effect of moving holidays, and as well we see and the evidence for yearly seasonality. And I also present a spectrum of the trended data where we can clearly see I marked the first 3 intra-yearly cycle peaks and the intra-monthly peaks. So we see that they're quite strong here. So the second example is weekly credit card purchases in Israel. Again, if we look at a monthly pattern, it kind of reverts to what we have seen before, because most employees in Israel receive salary during the 2nd or the 3rd week of the month, and that's why we see this increasing pattern, and that then decreases before the pay. Looking at the yearly pattern, we can also see something like these 2 drops that resemble what we've observed in initial registrations, because I guess it happens because many Israelis travel abroad and then they spend less within Israel. If I remember correctly, we have at least 1 million people living out of 10 every holiday, so that's quite significant. And so this finding is kind of corroborated by the spectrum on the right, where, however, the intra-yearly peaks are kind of weak. And the last example is just a textbook example of gasoline production in the US. Actually, it quite resembles most of the examples that I saw in the literature that are characterized by a single seasonal cycle, that is intra-yearly. So as we can see here, there is no evidence for intra-monthly seasonality, and there is quite a pronounced yearly cycle, and these results are corroborated by the frequency plot here. So and when I just started to work in it, I discussed it with a few of my colleagues from other banks, and I saw that people are just using some sorts of all sorts of packages that are available on CRAN. For instance, MSTL, Profit, TBATS, or STR. However, the limitation of these methods is, as I mentioned earlier, that all are assuming the constant number of periods in a cycle, and they are kind of suitable for situations where the seasonality evolves gradually or smoothly. But as we saw before, it's not the case here. So there are also some tools for seasonal adjustment of weekly data. It's the MUBREC programs that I mentioned before. There is also a fractional airline model that is available from the package Ecosignum, and I saw that it is also available from RG Demetra. And the last one is the package that I'm going to present today, which is a bit modified version of MUBREC. So briefly about methodology, it's quite standard. I assume that the series can be decomposed into trend, seasonal, holiday and working day effects, outliers, and the regular part. And T refers to the last day within a given week. Multiplicative decomposition is also available from the package. And well, in generally, in the package, H stands for any pre-adjustment variable inserted by the user. There is also a routine that is taken from the X12 method, quite standard, to detect additive outliers. So the seasonal component is modeled using trigonometric variables, where I take into account the number of days in a year and the number of days in a month that may vary. The precise precision of each observation within a seasonal cycle is taken here. And in order to allow seasonality to evolve over time, I use a variant of discounted least squares, where the discounting goes by years to prevent over rapid decay. So the algorithm is it's quite resembling the algorithm of the X11 methods. So I estimate the trend. So this is one difference from the MUBREC package. So it's done using a sort of local regression, and basically that's it. So then the seasonal regular component is estimated after the trending. There is an option for searching for additive outliers and to identify the optimal number of trigonometric variables. And then the whole process is rerun again to compute the final seasonal component and the trend. So let's see first the textbook example, because it's the most simple. Again, like less experienced users can use the automatic procedure. And as we see, I'm missing my, as we see here, you need only to provide the data as a vector plus the vector of associated dates, and that's it. The program will automatically search for the optimal number of trigonometric variables using information criteria, and also for additive outliers, etc. And on the right, we can see the resulting decomposition. And on the left, we can see also the spectrum of the original in green and the seasonally adjusted series in blue. So I use here the autoregressive spectrum with 60 lags. And I also detrend before computing the spectrum to make it easier. So and it kind of worked okay, and I don't show it here, but the automatic procedure choose 12 yearly trigonometric variables and 0 monthly, which is consistent with the diagnostics that we did before. So this example is a bit more complex. So this is a weekly number of registrations in the easily imported net service. So here we have 2 cycles, and I put the code snippet on the left. So what I do here is that I create the working day adjustment variable plus 2 moving holiday variables, which are a bit non-standard because the full influence of the holiday falls on a single week. So I just created dummies and centered them. However, one problem that we may observe here is that there is a spurious outlier detected here. So probably because I'm using a default value of the outlier threshold that is taken from X12. So maybe in some instances it could be useful to increase the outlier threshold to prevent that. So this is what I do here, and it kind of solved the problem. And now we have a smoother trend. Again, we can, after running the procedure, we can analyze the spectrum of the adjusted series and see that all seasonal peaks were eliminated.
Tim, you have 5 minutes.
Yeah, thanks.
5 minutes.
Yes, thanks. So what we also can see, this plot is generating using a function that is also available from the package. It's called the plot spec. So, and the last example is the weekly credit card purchases in Israel. Again, I create a working day variable using the simple TD function. And also I create the moving holiday variables using an adaptation of gen hol functions that I guess familiar to everyone here, which creates the moving holiday variable accordingly to the Easter formula. So it's just adapted to weekly frequency. So you need to just set the window where you think that there is an influence of the holiday, and that's it. Again, after running a procedure, we can examine the resulting spectrum and see that it successfully eliminated seasonal peaks. And basically, that's it. Thank you. If you have questions or.
Well, thank you, Tim, and thank you for ending early so we have more time for questions. Do we have anyone who would like to ask Tim a question? Well, if not, I have a couple. First of all, you stated that Ecce Signum was an example of using a fractional airline model.
Yeah,
it's not actually. I believe what Ecce Signum does is it can create components based on different frequencies, which I think would make it quite adaptable to your problem in terms of trying to target specific spectral frequencies in the weekly domain. In fact, Tucker McElroy, the main developer of it with James Livesey, he spoke at the joint statistical meetings and said that the fractional airline model had problems.
Yeah.
So
they mentioned that in the package.
Yeah. So I mean, maybe you can implement the fractional airline model within Ecce Signum, but the way I've worked with earlier versions in my tenure at the Census Bureau, and we were basically creating components based on frequency. So I mean, I think that part of Ecce Signum could be very well adapted to your problem.
That's interesting. I just haven't seen this example. They kind of, in the context of weekly data, they present the fractional airline model, and at the same time they warn against it. And so from what I see, yeah,
I thought James
it's worth trying. I'll play with it more. Yeah, thanks.
Okay. Yeah, I mean, James Livesey is in the room. Maybe he can.
Yeah, I am here. So Tim, very nice talk. I really enjoyed it. Actually, Tucker and I have spoken a few times about this package and have been looking at it. It's our approach when the periodicity is fractional is to actually put the, exact sinusoidal components in that would annihilate those particular frequencies in the spectrum. There's pros and cons doing that compared to the fractional airline. But yeah, exactly what Brian said, that if you're targeting exact components for frequencies in the spectrum, essentially that's something that we put the exact components with those exact frequencies in, and then we show that the fractional airline actually does not have exact zeros in the filters for those. It gets very close to zero, but it's not exactly. So yeah, I think that there's this nice thing. I think maybe we should find some time to chat about this. After this, because that was quite nice and illuminating talk.
If I could, I have another question. A colleague of mine read your paper, Tom Evans. Tom was one of the people who is behind. You mentioned you mentioned a package that BLS used to use to do weekly seasonal adjustment. We've now moved to another method within SAS where we're doing like basically unobserved component models to do the seasonal adjustment. And he was wondering why he was concerned that you were using least squares and was wondering why you didn't try to use the Kalman filter.
Well, in a filter, you need to assume a certain number of seasonal indices or a period. And that is then evolving. And as I showed earlier, so the point is that in most textbook examples, and also I think that in the Eurostat paper that is presenting the MoveRec package, they have a single cycle. So the problem is kind of less severe. When you have a monthly cycle as well, it looks completely different. So it's much, so the distortion is much stronger. I have a feeling that in the case of a single cycle, even using a variant of STL, say, would do a decent job because the distortion is not that strong. So that's why and in addition, Kalman filter is kind of more complex to fit. So it takes more time. So honestly, I have a draft for MoveReg now, but I found like playing with 2 parameters of decay a bit tedious, and that's why I switched to the discount weighted regression. And in addition, it has a sort of it has a statistical theory behind that. So now it's just an algorithm because I split it the steps of detrending and modeling seasonality, but potentially you may have a statistical model behind that, which is very easy to compute. It is fast and it is fairly robust compared to Kalman filter based methods that can be that have temper sometimes.
Well, I'd suggest you might want to contact Tom Evans because he has, as I said, he's developed like I said, within a SAS framework, he's developed this Kalman filtering method. Might be interesting. I also noticed in your graphs, I noticed a very large, particularly in the credit card debt, a very large pandemic effect. At least I interpreted it as a pandemic effect because it begins in early 2020. Can you give us some details on how you explicitly manage that effect?
So, well, it's kind of complex dealing with prolonged events like the COVID-19. So we have the same problem, even more severe with initial registrations. So like people were on a paid leave for over a year in Israel. So it completely changed the structure. And so here, the procedure identified. So with credit card purchases, it is you see a large, significant decline, but in terms of seasonality and like the overall structure, there are just a small number of not a small, but there is a number of additive outliers as well. And for this series, I put a decay rate to 0.6 just to forget it faster. So
yeah, in our univariate modeling, we tend to try to look at. I mean, I tried to look at varying the decay rate for what we call temporary changes to model the effect. I mean, yesterday there was a talk on that by Eric Valentine.
So probably it is an option as well. I need to add a procedure to create temporary effects as well.
Mm-hmm.
So, well, yeah, another thing that came to my mind and that I liked, it's quite an antique method, discounted weighted regression, but it's interesting that you can assign a different decay rate to each parameter. Even so, it is not practical when you have like 50 coefficients, but in high frequency applications, for instance, to daily data, you can assign a different decay rate to each group, to each seasonal cycle. So it could be useful as well.
Okay, well, I think we have to thanks for the comments.
Thank you.
I think we have to get going up, and we have